Welcome everybody. I thought I would give a little video to give a little bit of help on our shellcode analysis part of the lab. And the reason for that is there's just a few people who've really been struggling with that, and so I thought I would offer a little bit of guidance. Okay, so first thing I want to bring to your attention is now with this tester, I assume at this point with our previous videos you know how to do this. You can get this far. One line that is missing is this line, user 32DLL. So when the shellcode was created, it was reliant upon user 32DLL being loaded. Well, guess what? If you use this test offset script, it will not be loaded. And as a result, your shellcode will break at a certain spot and it will terminate. Part of it will be done. Part of the function table will be filled out, but the function table pertaining to user 32DLL, those functions will not be populated because it'll break because user 32DLL is not present, and therefore when it's comparing the hashes for that, it'll never find it. So what we do instead here is just add one little line, and that little line makes sure that user 32 is loaded for you. And so if you go and run it like this, actually let's go ahead and get going there. We do LMF, and we see user 32 is now present. So we're in good shape. Hit G for go, and then that'll take me over here. I'll jump to EAX, and then I come upon, well, let's just go through a few of these, and I think if you just keep on clicking it, you notice a pattern, right? So, and of course you can determine that just by reading the disassembly, but if you were confused, that may make sense. So there's some kind of something going on here. Now one thing I want to do is I want to be able to get to this EAX, but as you can see, this just keeps on going. And so what I can do is I can do a run to cursor, or I can do a breakpoint. I'm just going to do a breakpoint. And I'll just hit G for go. And that will take me, it's going to call to that location. So all of this has been done. And I'm not really going to explain what's going on here because that's part of what you need to figure out for the analysis. So we'll skip over that, I guess. And so then that takes me over to this location here. And I'm able to see some stuff that I wasn't really able to see before. And it's nice to be able to look at this inside of WinDbg, but it would be nicer if we could have it in IDAPRO. So what we could do is we can extract that from memory. I guess another option is you could, instead of using WinDbg, you could use x64 debug, and they do provide a graph view. So if you would prefer that, feel free. But I'm not going to show you that. I'm just going to show you one technique here. So what you can do is you can go to hexd. You just type hexd, and it should pop up. And close out of that. What I'm going to do is I'm going to open main memory, and I'm going to find my process. My process is right there. So I've opened this in memory, and this is just another way we can extract memory. You can do it through Process Hacker. That way, if you do that, you have to go in there and search and try to find the exact location. And if you know exactly where you want to go, then I don't know, maybe this is easier. So I want to find this call E. Actually, no, I don't. I want to find this call right here. So if you go back to your shellcode, this will match up roughly with this. There are some differences, but it has been built off of this. So again, there will be some differences, but it will be similar. And you may recognize the sub ESP1000. You see, I think we have this there, maybe not. We have this call to a label, which we've discussed those before. So right here is the starting point of this variation there. So I want to get 30016. Let's go to my hex D. I do Control G. 30016. And I want to match up and make sure it works. And I see immediately C3. C3 is return ret. That's something I know. C2 has a variation on that, I believe. A more obscure variation. And we see the C2 right here. It's been used for something different. But this is our C3. So it did take us to the right location. At this point, we don't necessarily know how much we want to copy. If you go back and you look very closely at some of what's going on in the disassembly, you can figure out how many you need to go. But I'm just going to say, let's try 1,000. And of course, when you compile this, it's and you use the PVE bin, you can obviously see it's much less than 1,000. But we'll just play dumb and pretend like we don't know that. So what I'm going to do is I just go like this, and then I can just go select block, and I'm going to go 1,000. And it doesn't go that far, which I knew that, but I can see all of memory, and I'm just gonna pick a location that I think is good. So we start here, it goes down here, and maybe I'm not sure what's going on with those, so, or even with these, maybe I'll just go to this location here, and it's just a guess. It's not really based off of anything here, and you'll see why it doesn't necessarily matter too much if you're off. So I went from length to end offset. I'm going to go right here, 30E30. This is not a very intuitive right there. It's very annoying. Okay. 30E60. Okay, so I'm copying it, and I'm going to say I'm pasting it here, so, well, actually, let's just go ahead and do that here. So in that case, I did E40. Here I did 570. So a lot less, but it doesn't really matter in this case. And I'm just going to stick with this because I have my IDA Pro on a different VM. So I've extracted it here. I'm going to go dump it inside IDA. And it's a binary. You need to have, I think this will only work in the professional or educational version of IDA. So if you have, I'm not sure if it works in demo. It didn't used to. It's possible it may in demo. Binary Ninja is another one you could use, which we haven't really discussed in this class, but you can get to the location and you can right click it and it says something like make a function, and you'll want to do make function for Windows x86 at the offset. We'll see what we mean by the offset in a moment. So it's 32-bit, and we need to tell it where to start, and I kind of went very quickly. But you find the location, the offset, and you hit C, and that tells it where to start interpreting the assembly. So this is the same assembly that we had before. There's that C2 that I was talking about. We start right here. Sometimes if you have malware or really complicated shellcode, it might start right here, and that's a way to trick people. But we start right here, so we hit C. And now we can see the shellcode. And as we continue on, we see that some of the stuff here, IDA doesn't know how to interpret, and that really just means we took more than we need. And IDA doesn't know how to make sense of it. This part here, the instruction and the regular function, that's the part that we care about. So we can disregard the rest of that. So we can use this as a guide to kind of figure out what's going on. So what you would probably want to do is compare it with the other one that we have right here. If you've watched the video or you looked at this, you probably have a fairly decent understanding of what's going on. And of course the labels here are a little bit more intuitive. So what you would want to do is think, okay, where would I want to go in order to figure out what's going on here? So if I watch the video carefully, I know most of what's going on here. It's just the new functionality that I'm kind of unsure about. So you could think, here's the to-do. Can I find the to-do section over there? And so if I think back to IDA, I mean, I don't have these nice labels, but I can recognize some of these are going to be more or less the same thing. So let's go return to IDA, and it's in another VM, so this is slightly awkward. And I pulled it out because I'm using two different monitors and I have them both open. So I can go back up here to the top. I see this load effective address. We have hash table, we have our functions hash table, we'll have call get API address, we'll have our pop edx, pop ebp, and then this right here, this is new stuff. And so if I can get to this point in the code, I can maybe figure out, okay, what's going on with this, what's going on with this, what's going on with this, because these things probably would have been populated. So let's go on over to IDA. We're in IDA, let's go to WinDbg. And I see the label here is at 3000112. And I'm just going to say, you know, let's call this 12. And I can go over to IDA. And that right there is 0. So there's a difference of 12 hex. So if I want to get, say, to this location right here, I could do 33 plus 12 hex. So I have the 12 there, plus 33 equals 45. So 45 is the last little digit there. So and I can look ahead here. And the result there is 45. And that looks to be just a little bit off. So something with the math there is not quite right. But that's okay, because I can visually see it and inspect it, and I can see that maybe I want to go there. So I put the breakpoint there. I hit G. And now I can access some of this information. So I could do EDX plus 163. And I see that it's a 0. Okay. Maybe it's a parameter they're using. And then right here I see this. What is that? It doesn't look like a name to me. It looks like it's probably some... Is it an address maybe? And that says get... So this is probably the point where I think I've showed you enough that you could probably figure out the rest of what you would need to do. And I apologize that I have these on two separate. So you can go here and you can try to populate these different things and figure out what's going on. What are the parameters that are being pushed?